Okay, so first we're going to start off with modeling quadratic functions. Okay, so with that one, hopefully that doesn't mess it up. So you can always write an equation. You guys want to see it? There we go. You can always write an equation when you are given 3 points. Okay? The reason for that being is if I gave you 2 points, how do you know what the shape of the graph is? Is it going to be a line? Maybe. Can it be a parabola? Maybe. This third point could either go up like this or down like this. We don't know. Okay? So that's why we always need 3 points to be able to create an equation. Okay? So these are our steps on how we're going to type this into our calculators. And our calculator is going to give us a regression. Okay? So with your calculator, and if you are a steps person, you can write these steps down. Also, since I'm recording this, I'll save it onto our page. So if y'all want to refer back to it, you're more than welcome to. So the first thing we're going to do is we're going to go to stacked. How many of y'all don't have a list 1 or list 2? Like you don't see an L1 or don't see an L2 when you go into stat? Anybody? Okay, if you don't have an L1. Oh, so go to edit first, press enter. There you go. So if you do not have an L1 or L2, all you have to do is go back into stat and go down to setup editor and press enter until it says done, and then it'll come back. The reason for that being is someone either pressed delete and it deleted the whole column. Okay, so in stat, how many of y'all have numbers that are already there? Okay, so if we go to edit, if you scroll up to L1, you can press clear enter. And it deletes the whole column. Okay? Not deletes, it deletes the numbers in it. Same thing, go over to L2, go all the way to the top, press clear, enter. And it clears out all the contents in the chart. Okay? So your L1 is your X, and your L2 is your Y. Go ahead and enter in those values if you haven't already done so. Then we're going to hit stat again. We're going to go over to calc. And we're going to go down to quad reg. Okay, we are in the quadratics chapter. So we are doing a quadratic regression. Remember the good old days when you did line of best fit? Same thing, but for a parabola. Okay? So press enter, and then you can press enter all the way down to calculate, or you can scroll down all the way to calculate. But then once you press calculate, it gives you some information. It gives you the formula, it gives you A, it gives you B, and it gives you C. That is an equation that fits this data the best. In this particular case, and we're going to talk about something here in a second, it actually fits it perfectly. So y equals A, which is 1. We don't need to write that. Minus B. So we have X there plus C. How many of y'all in your calculator have an R squared that pops up? Okay, so not all of us have it pop up, okay? So here's how we're going to make it pop up. On your calculator, go to second catalog, which is 0, and scroll all the way down to diagnostic on, or you can do alpha D, I think twice. We'll get you to the D's, and then go to diagnostic on. Press enter. It should say done. Okay. So from there, does everyone know the second entry trick on your calculator? That you can press second, enter, and it pulls up the last thing you did. You can do second, enter again, and it pulls up the next thing you did. So if I pull up my regression again, I should see my R squared. Now, if you don't know how to do the second enter part, then you can just run your regression again, and you'll see your R squared now. Okay? So what does that even mean? Okay? So R squared is the measure that pretty much tells us how close to the data points is this equation they created for us. So when they create an equation, that's just them saying, hey, I got your data, and this equation goes through majority of the points, or it gives you kind of like a baseline of what would go through that, okay? Like an estimate, if you will, okay? In some cases, it goes straight through every point, kind of like the last problem we just did. But if you notice, the closest to 1 means the closest the points are to your line, okay? You notice over here, 0.26, this makes a zigzag. This is nowhere near the shape of a parabola, okay? So that is your correlation coefficient, okay? See if I can spell this correctly. Correlation coefficient. 2S maybe? If you know how to spell it, you can spell it better. Correlation coefficient. Do what? I hope so. So the closer we are to 1 or -1, and that would just imply that we have a negative slope or anything of that nature. The closer we are to 1 or -1, the better that line fits our data, okay? We're going to get to a point, if not a little bit in Algebra 2, but definitely in pre-cal one day, where you're going to be given some data, and basically you have to figure out which equation fits it better. So in other words, it could be a line, it could be a quadratic, it could be a cubic function, it could be all kinds of things. It could be a logarithmic function, okay? So that's what regressions are going to help us with. Any questions on the correlation coefficient? Okay. So like I said, R squared, the closer it is to 1, the stronger the relationship that data is to that line, okay? And you might want to put in there, well, not on R squared. On the other ones, you'll look at R, and it could be -1 as well. The closer or the further away it is from 1, that's a weak relationship, okay? So if I just have random dots going everywhere, they don't really show the shape of what it could be. They'll give me an equation, but it probably won't be the best fit for our data. Any questions on that? Yeah.
Could it be above 1?
I don't think I've ever seen that before. So the question was, I don't know if y'all heard her or not. She said, could it ever be above 1? Okay. So I've always seen an equal 1, like the last one we did, but I don't think I've ever seen it go above 1. So I think 1 is like our line there. Good question. That email I just got, it reminded me too. Just a heads up for y'all's first block. Tomorrow they're doing a fire drill, so just so y'all are heads up on that. That's going to be neat. Yes.
I just Googled it real quick. If it's greater than 1 or less than -1, means there was an error in the correlation measurement.
Oh, cool. Oh, the Google. What a powerful thing, you know? We were talking about that in the workroom the other day, and I said, yeah, my mom used to say, I don't know, go look it up in the encyclopedia. And I'm like, seriously? And I'm not that old, but Google really wasn't a thing. Okay, so just looking at this correlation, does it look like it has a strong or a weak correlation? Strong, okay? You can see the shape of this graph, okay? And because it is going up, this would be a strong positive. Strong positive correlation, okay? Those are easy to see with lines. Okay? That line doesn't go through every single dot. But if I ask the question, if this is time over here, hey, in 20 years, about how much money am I going to make? I don't know. Okay, so then I could go here, I could use that equation because it's going to get me in the ballpark. Is it going to be the exact answer? Maybe, maybe not. Okay, but it's going to be in that ballpark. Okay. What about the correlation here? Weak. No correlation whatsoever. Okay. I don't know if this line is going this way, if it's a parabola, if it's another line. I just don't know. Your calculator will give you an equation, but it's going to have a really weak correlation. Okay. And then this one, strong negative. So if you notice on these 3 examples, well, 2 really, that they're lines, we won't look at R squared on those. We would look at just R. Okay. R squared, you're just going to look at with quadratics. Okay. So that's why you'll see both positive and negative. Okay. Let's go ahead and get more practice plugging this in. You will be so familiar plugging things into stat before you leave algebra 2 will be unreal, okay? So just get comfortable, see how far you can get without referencing your notes. Go ahead and plug that in. Remember, highlight L1, press clear enter if you want to clear the entire list. All right, so I should get negative 17.5 x squared plus 74.5 x plus 157.5. You notice my r squared is 0.836 and so on. It is still a strong correlation, but it's not perfection, okay? So the one problem we did back here, our r squared value was 1. That means that these dots, or these ordered pairs, were exact, okay? But the one we just did is pretty close, it's not perfection, okay? That's just the main difference between those two. Anyone having issues plugging these in? These are the thank you questions we move on with, okay? So make sure that you know how to plug those in. Try this one. How is it using Algebra?
Just not. Does not like me.
At least it works. Okay, so this particular one, we get A is negative 0.08 x squared plus 1.68x minus 4. And my r squared is 0.9, which is pretty good. Okay, again, not perfection, but it's even closer than the last problem of 0.6 or 0.86, sorry. Any questions on this so far? Please let me know if you're getting anything different on your calculator. If I can help you. Okay. All right, go ahead and do this problem. How is this different from the problems we've been doing?
It's asking for the.
Do it. Yeah, not that part just yet. That's why I covered it up. How is this different from what we've been doing?
It gives you coordinates.
Okay, it's coordinates. But do y'all remember back in the good old days of Algebra 1? Where they told you to write out ordered pairs, but then they told you to change it into a T-table or a table. And then they made you do that good old, remember that mapping? Where you had to draw from one to the next. Okay, you had to draw arrows and whatnot. And then you had to graph it, whatever it was. And they made you do 4 of those things with every single problem, and it was so annoying. Okay, well, there was a little bit of a reason behind that, and that's knowing that there's nothing stopping me from getting a set of ordered pairs, which is a relation, and writing it as a table. Okay, but for some reason, this question will pop up on a test or a quiz, and you'll be like, I don't know what to do here. Okay, you're just going to solve it like you've been doing. Okay, so go ahead and plug that in. Okay? So if we have an equation and I wanted to know the vertex, okay? So right now, we don't quote unquote know anything, even though you learned it in Algebra 1, okay? So go to your y equals in your calculator and let's plug in that equation that we got. Plug it into y equals. Some of your calculators might be off, so you might need to do zoom 6, gets it back to normal, gets you a normal 10 by 10. Your calculator messed up in any kind of way. Then in y equals, type in negative 2x squared plus 4x plus 1. And remember, x is right below mode, in case you're looking for that as well. Uh-huh. You type in it's in negative 2x squared. Yeah. And then plus 4x plus 1. And then graph. Yeah. And then yours might break down on you a little bit because the plots are on. Just press enter on those. Press enter. Press enter. Now do the equation, and then once you put the equation in, hit graph. Okay, so a couple different ways you can approach this. We can trace the equation on here, or go to second calc and notice there is a maximum and minimum button. Okay? What was the shape of our graph? Did it open up or down? Do what? You can write X with the square. There you go. So which way did it open? Up or down?
Open down.
It opened down. Okay? And we're going to get into all these little details tomorrow and everything like that. But it opened down. Okay? So if it opens down, am I going to have a maximum or minimum up here? A maximum. So pick the maximum button and press enter. It's still my eraser again. Yeah. Second calc. And then maximum. Okay, if you notice at the bottom of your screen, it asks you a question. It says, left bound question mark. Okay, so hit clear. Yeah, and then you can turn the plot off too. Okay, so it says left bound question mark. Does anyone not see that? Let me know so I can help you.
How do you turn off plot?
Do it.
How do you turn off plot?
Oh, you turn off your plot so it doesn't get confused. And then let's do zoom 6. There we go. Now go to second calc.
What is that at? Calc?
Calc is up at the top with trace.
Oh, I see.
Anyone else? Okay, so what it's asking you for a left bound. It's telling you, hey, I know there's a maximum somewhere, but I need you to tell me what boundaries to look at it in. Okay, so for example, if we have our parabola, and this is our vertex or our maximum, okay? Notice how there's a blinking spider on your calculator. And if it asks you for the left bound, you just need to make sure you're somewhere on the left side of the mountain, okay? Doesn't matter where you are, just have to be on the left side. Press enter, and you should see a dotted line appear, or you'll see a triangle appear, or you'll see both. Uh-huh.
Every time I press, see that.
There you go. Okay, so now it asks you the question, right bound, question mark. So travel to the right side of the mountain. Again, it doesn't matter where. Once you press enter, a line appears and a triangle appears. And then it asks you to guess. You don't have to guess. If you want to, you can move it all the way to the top of the mountain if you want to. Or you can just press enter again. And it tells you it's about 0.9999996. So in other words, 1, 3. Okay. So that is where our vertex is located. Vertex will also contain your maximum or your minimum. Okay. Did anyone not get that when they plugged that in? So if you go to second calc and choose maximum, so see the little spider? So it says left bound. You're going to travel over here, press enter. So then an error popped up, so it's created something here. Now I'm going to travel to the right side of the mountain, press enter. So it's created a boundary and it's going to find the maximum there. Uh-huh. That's okay. We're rounding. We've all got 1, 3. Yeah, if you got 1.00, whatever, same thing. Okay? Any other questions on that? So now it asks us the questions, what are the x-intercepts? Who remembers what an x-intercept is? Michael? Michael, right? No! Anthony!
Isn't it where like the line passes the X? Like where X is here?
Yeah, good job, Anthony. I'm going to call you Anthony from here on out. You're not going to be Michael anymore. I wish I could justify like a Michael sat there, but I can't. First day, right?
Is this supposed to have a question?
Is this supposed to have what?
Like a question?
No, you're good. Okay. So how can we find this on our calculator? Very easily, okay? Same idea. I think I have the same steps here. So that's for a maximum and minimum. This will all be on your notes if you need this for later. I think what I'm also going to do is a tutorial on how to do that where you can see it in case you need to learn that as well. So our x-intercepts. Okay, go to second calc. You're still on the graph. Go to second calc. There's another word for x-intercepts, and that's called zeros. Go to option 2. Press enter. So now we're looking at a parabola. And we want to know, where does it cross the x-axis? Okay? Notice how the same questions pop up, left bound, right bound. Okay? So we're going to find one at a time. So I am going to travel over to the left side of the first zero I want to find. So I'm going to travel somewhere over here. And then I'm going to press enter. Then I'm going to travel back up, but not enough that I include this dot, just enough that I get a good barrier to basically say, hey, between this dotted line and this dotted line, I want you to tell me where it crosses the x-axis, okay? So you press enter, and it tells you -0.220. Okay, does it cross in another spot? Yeah, we're going to do the same exact thing. Go to second calc. Go to option 2. And I'm just going to make sure I pick somewhere on the left side over here. Press enter. And somewhere on the right side over here. Press enter. Press enter one more time. And it also tells you 2.220. Did anyone not get that? Okay. Please let me know if you did not. I can help. So today is mostly just working with our calculators, okay? The next couple of days, what we're going to be doing is we're going to be doing this by hand, okay? All right, so let's check this one out. I have a funny story for y'all. My husband and dad and brother went golfing this past weekend. Did I tell y'all about this? Okay, so they went golfing this past weekend. And my husband's more of like an outdoorsy guy. He likes to fish and hunt and all that stuff and everything. And he used to golf, but he doesn't really golf anymore. And he decided, I'll go with him this time. And what happens to him? He gets hit by a ball, y'all. The guy behind them just like has a line drive and just hits him so hard in his back. And he's definitely feeling it. And it's a good bruise. Like, it's huge. But, I was like, of course, the one time I finally get him out there to go golfing, he's like, gets nailed in the back. Oh, man. But anyways, a golf ball was hit upward from the ground level. And we have our table here, okay? So go ahead and figure out. Oh, good. I can move that. Go ahead and figure out our equation. And then answer the 3 questions that go along with that equation. Okay? Go ahead and do that really quickly. Okay, so if it's not showing up on the graph, you have to change your window range. Okay? So go to window, and you're going to start messing with your both your X maximum and minimum and your Y maximum and minimum to see if you can fit the graph in your screen. So if y'all notice when you're looking at the numbers of height, they get as high as 832, okay? It could probably go further than that. So after you find your equation and you're plugging it into y equals, you're going to have to change your window range, okay? All you have to do is press window, and then you can mess around from there. Now, there's also another option, zoom fit. You can try zoom fit and see if it fits it in the screen for you. Like every time? Oh, because you put a minus sign, it's going to be negative. So you need to use this button down here. Yeah, so go to y equals, or did you write it down yet? Write it down and then plug that into y equals. There's a way to do it where you can like paste it in there, but sometimes it's easier just to write it down. Did you forget an X again? Let me get this one out real quick. All right, so our equation should be y equals negative 0.16 x squared plus 30.4x minus 288. And just be careful when you're plugging this in that you're using a negative when it's up in the front and an actual minus sign when it's an actual sign like that, okay? So let me see here. Did it show up? Okay. Okay, when y'all changed your window range, what did you find was the easiest scale to use? Anyone change your window? Or did someone do a different thing? Yeah.
I changed my window.
Okay, what did you change it to?
I changed all of the minimums and maximums to 1500.
All of them to 1500?
Yeah, but like the negative.
Oh, gotcha. Okay. So sometimes if you just go to the extreme, the whole thing is I just want to see the top of the parabola or the bottom of the parabola. So if you have to go to the extreme of just saying negative 2000 to 2000 and so on, go for it, okay? So let me change it real quick. So I see my top of the parabola, which is also my maximum. And they ask us, what is the highest point, okay? So let's go ahead and find our maximum. Go to second calc. Go to maximum. I'm going to do my left bound and then my right bound. And the calculator tells me 95 basically, and 1,156. Okay? Yeah.
How do you get to like the top of the problem?
That's what, so go to window and change your X max and X min and Y max and Y min to like, you can do 2,000 if you wanted to. Just do like negative 2,000 and 2,000, negative 2,000 and 2,000.
Do we need to keep it there?
Do it.
Do we need to keep it there?
No, Zoom 6 gets it back to normal. So when you want a normal 10 by 10, Zoom 6 just changes it back. Anyone else having issues not seeing the top of their parabola?
Let's see that.
Do it.
Okay, so when you can enter, can you go back?
Just press back. There you go. Anyone else?
How do you zoom in?
So go to window and change that to negative 2,000 and then 2,000, that to negative 2,000 and 2,000. Okay, so looking at this part of our vertex here, when I want to know the highest point the ball goes, what number is that? 1,156, okay? That is your height. You notice your Y value is your height. Your X value is your time, okay? So when will it reach its highest point? 95 seconds, okay? So you got to be able to pick apart what are they actually asking you for, okay? Now if they turn around and say, well, what's the height of the ball at 45 seconds? What do we do?
Plug in 45 seconds for X.
Perfect. Plug in 45 seconds for X. So I'm going to take this same equation and the normal place I plug things in, and everywhere I see an X, I'm just going to plug in 45. Oh, come on. So then I just get out of the graphing, I go to my normal home screen, and I plug in 45. So I should reach about 756. Anyone not getting those values, please, please, please let me help you. Okay, so go to second calc, and then go to maximum. So left bound, we're already on the left side of our mountain, so press enter. Let's just right down, travel all the way across the mountain. There you go. It doesn't matter. Press enter. Press enter one more time. There you go. Any other questions that I can help with that? Okay, so when we ran our regression, it actually said that our R squared was 1. So that is a perfect fit for our data. Does that mean that the ball, the way it travels, is going to be perfect? I don't know, probably not. Maybe, it might. So this is just kind of a ballpark of what it could possibly be if it keeps following on that same trend, okay? Let's see. right, let's try this one. All the way through, answering all the questions. And then I'll kind of walk around if you're someone that still needs help with how to plug it in. Let me know. If you're unsure about number 1, we're going to come back to that. It's something that will haunt you the rest of your math career, domain and range. It hasn't haunted you yet. And then answer from there. Is it working now? Okay. Zoom 6, always get your calculator back to normal and then you can redo the window range. You notice your R squared value on this one is not terribly close to 1. It's still a good fit. It's still a strong fit there. It's not the best fit, but it fits the majority of the data for us. If you notice after you graph this, and if you did Zoom 6 to get it back to normal, you really didn't have to go too much higher on your Y maximum to see your graph. So I only changed my Y max to 20, and now I see everything I need to see. you are not getting those values, please let me know. No, I don't have the R on there. No, that's what my R was too. Did you? Oh, because you gave the 3, yeah. And that's okay, it's gonna be a ballpark anyways. Yeah. You put 30.4, that's one of the other problems. It happens. So if I look at my chart, and I'll be right there, and I noticed it says at 4.5 seconds, which is right in between here, I better be in between 9 and 4, okay? Is it gonna be perfect? No, but I should at least be in between 9 and 4. Okay, yes?
When getting off of 1.931 to 11.27, do you want us to go to hundreds?
If I specify, then I want you to follow suit. If I don't specify, then it's fair game kind of thing. The question was, do I want y'all to always do hundredths place? And I basically said, if I don't say round to the nearest hundredth, or round to the nearest tenth, or round to the nearest whole number, then I can't be picky on your answers. So then it'll become kind of like a ballpark, right? So that's why it's super important to show me what you're doing. Anyone else with how to plug those in? Okay, so domain and range. Yeah.
X and Y.
Okay, so your domain is your X values and your range are your Y values. Now, in the context of this problem, what's my domain? Do what?
Seconds.
Okay, it's our time, all right? But looking at your graph on your sheet, or on your sheet, your calculator, okay? We're showing, at least on here, at 1, about how long does it take us to hit the ground again? So go, what you could do is if you wanted to just trace it, you can go to just click the trace button and you can trace all the way down to our 0 there. And it's about 5.5, okay? So our time, our domain is gonna be our time the skier takes trying to think of the best way to phrase this. Time it takes a skier to go up off the ramp and back down to the ramp, okay? And that takes about from 1 to 5.5 seconds, okay? So those are the things I want you to write down when it's talking about in context of a problem. It's the words, okay? So takes to leave and return to ramp. And then somewhere I would put in there 1 to 5 seconds, okay? 1 to 5.5. Our range, on the other hand, are our Y values. That's how high the skier is going, okay? So he's gonna bottom out at some point over here, so 0. And then the highest he can possibly go, well, we found that, 12.25, okay? So your range you would write out is the height in which the skier goes, and that ranges from 0 to 12.25, okay? So, which actually, according to this, he goes higher. He actually goes to 15, And remember that this equation here is just a ballpark. Okay, so maybe I would include 15 since it is on the stats there. He goes anywhere from 0 to 15. Okay, feet. But that's, unfortunately, that is as hard as these problems get, is like having to do the words part of things, okay? But then plugging in the calculator, plugging in the answers, all of that is pretty straightforward, okay? Any questions on all of that? Okay, let's go ahead and start our homework.